We're going to begin by talking about our exponent rules, and first you need to remember what an exponent is. So an exponent is a base power, so a number or it could be a variable, raised to an exponent or raised to a power. And we write them as like a little number above our base number. We can have that as a variable, so we could have x raised to a number, or we could have a little term. So let's say we had 2x to the third. This is a monomial. It's one term that's got numbers and variables showing them added together. We'll talk more about that later. But the only base here that's being raised is actually the x. So remember that exponents are just a way to represent multiple or repeated multiplication. So for example, 4 to the third power is really just 4 times 4 times 4. It's not 4 times 3. That's a misconception a lot of people get, and they try to multiply 4 times 3 and get 12, and that's wrong. It's 4 times 4 times 4, which is 64, because 4 times 4, 16, 16 times 4 is 64. So make sure you understand this is expanded form of actually what's happening. The base of this would be 4. So the list here of 2 to the first power all the way 2 to the 10th power and 3 to the first power to 3 to the fourth power, you should know them. Those should be the ones that automatic you know what those are. Those will help you with problems when you work them. So we're going to cover 5 of the basic exponent rules. There are more than 5, but we're going to cover 5 of them. The multiplying, which is the product rule, dividing, which is the quotient rule, power of power, the zero and negative rule, which are sometimes referred to as special rules. So the first one we're going to start with is the product rule. And the product rule, the kind of way to help you can make it like a little index card or a place to put all these rules at one spot. So this is kind of an example of kind of what the formula would look like. So we have an A, which is our base, and another A, which is our base. So it says when you have the same bases, so our A's are the same, you add the exponents. So here our M is our exponent and our N, we would actually add those together. Oh, I left off my little plus there. Add those together. So we got M plus N. So let's do some examples of this one. So the first one, 3 to the second power times 3 to the third power, we can think about this as 3 times 3 times 3 times 3 times 3. So we actually have the same base. So we have 3. And how many of those do we have? We have 5. So this kind of helps you see why it works. So we have the same base of 3. So we keep the base and we add the exponents. 2 plus 3, which gives us 3 to the 5th power. We would then simplify that further. You can use your calculator, and in your calculator, when you put the number in, it's 3, and then use the caret. It's right under the clear button, and then the 5, and that will put it in your calculator. On Desmos, you can use it's A to the B power little button to put it in, or on your keyboard, it's Shift and 6. That's the little caret on your keyboard. So Shift and 6, which has the little thing above it. So that will give it to you on your keyboard. Now, if we look at option B, we have the same base, A and A. So we keep our base and we add our exponent. So 5 plus 4 is 9. Now notice for C, we have the same bases, all of M, so we keep that, but we have some negative exponents. We're still going to add 7 plus a negative 2 plus 3. So when we add those together, M, 7 plus a negative 2 is 5, 5 plus 3 is 8. Now, with D option, we have a 2-star here. Notice that our base, what has exponents, is the x's, okay? 4 is not part of our base, 2 is not part of our base. So we can almost think about this as 2 separate things. We have numbers. So if we think about 4 times 2, we know 4 times 2 is 8. So we just deal with the numbers like regular. And then we have x, the same base, and we're going to add the exponents. So we get 8x to the 7th. So notice on example E, we have a base of x, a base of y, and a base of x. We cannot combine x and y bases. They're not the same. So the rule doesn't apply. We can't say x, y, and then put this as 10. Can't do that. So, but we can combine the x bases. And we have 2 and a 4, so we add those together and get 6. Y doesn't have anything combined with, so we write him last. And we like to do this in ABC order. Our next rule is our quotient rule or division rule, and this textbook formula is our like bases, and then we take our exponents and we subtract them. I like to think of my division sign as a big subtraction, so we keep our base of a and then m minus n. So we have here. So when you have the same bases, you subtract the exponent. So let's do a couple of these. So we have the same base here of x, so we're going to keep our x. And then it's 5 minus, think of this as a big minus, minus 3, so we get x to the second. Now let's look at our next one. We have some negative exponents here, and we're going to think about those the same way. Our base is x, so we're going to keep our x, and then negative 7 minus a negative 2. Remember, when we look at these, we have two negatives side by side. That's actually a positive, so we can think of this as x, negative 7 plus 2, which gives us x to the negative 5. Now, this is not simplified all the way, but we haven't talked about this rule yet. So we'll talk about this as we go, so you'll understand what to do with this, because we should never have negative exponents in our final answer. Now, let's look at C. 4 to the fourth power and 4 to the first power. Now, if there's not a number written here, if there was no number right here, we would still know that there's an accepted or a known invisible 1 there. Any number has a visible 1. So we have like bases, which is 4. Do not confuse if nothing's there with that being a 0. That's very different. So we have 4 minus 1, so we got to the third power, and we would then have to evaluate this. 4 times 4 times 4. Remember, this is the same thing as 4 times 4 times 4, which we know is 64. All right, let's look at D. Now, D looks a little different because we have some numbers and then we have our bases. So our numbers we can think about as a little bit separate from our bases. This is 12 times x squared. So if we wrote this out, this would be 12 times x, 12 times. Okay? And so we can think about just our numbers individually. So 12 divided by 6, we know, is 2. That takes care of this part right here. Now we have like bases of x, and we're going to subtract 12 minus 4, and we get 8. Now, if you'll notice here, we have, why that little plus is there, we have m, a product on top, and then we have in division. So you want to kind of simplify first. So we're going to look at this base first of m, and we're just going to look at this top section right here. So we're going to keep our base of m, and because we're multiplying here, we're going to add these together. So we get 15. We didn't do anything to the bottom, so we're going to bring it over. Now we can use our quotient rule. So M15 and M17 being divided, we keep our base. 15 minus 7. So 15 minus 7, and we still keep our base. And when we think about what we have here, 7 to get to 10 is 3, plus 5 is 8. All right, now our next rule is a power of a power rule. This is when a power is raised to another power, when then you multiply the exponents. So we have a power of a, and it's raised to an exponent of m, and then the whole thing is raised to an exponent of n. So we actually multiply m times n, and we keep the base. So here's some examples with just numbers to start. So we have 2, so that's our base. That's what's being raised, so we keep that. And we have 3 times 4 is 12. We would then simplify this down 2 to the 12th power, and you could do that with your calculator instead of, if you didn't remember what those were, because that's not one in our list, we only do 2 to the 10th power. We have 4,096. All right, let's look here. So our base is x, and then we multiply 4 times 6, and we get 10. Now, our 1 star C here, we have two separate things. Remember that a number has an exponent of 1 even if we don't see it. So what we actually see is 2 to the first power being raised to the third power and x squared being raised to the third power. So when we multiply this piece, we're saying 2 to the third power, and these we're multiplying, we have x to the 6th power. Now we can simplify this 2 to the third power down. Remember, this is what it means in expanded form. 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So this is actually 8x to the 6th power. So pause for a minute and see if you can do D, and then check your work. All right, so your final answer should be 81, x to the 4th, y to the 8th. All right, our next rule is the 0 rule and the negative rule. And so the 0 rule is pretty cool, but you have to be very careful with it. So it's any base raised to the power of 0 is 1. So here's our formula. A base of a raised to 0 is 1. So if we raise 5 to the 0, we get 1. 247 to the 0 power, we get 1. Negative 5, notice the parentheses. The whole negative 5 is being raised to 0 power, we get 1. But when we don't have parentheses and we have a negative involved, we have to be very careful. So what the base is here is just the 5. 5 raised to 0 is 1. Then we have to apply the negative, so we have a negative 1. The same thing if we have parentheses and we have a negative outside. Whatever's in parentheses here is being raised to 0 power, so it's 1, and then the negative is applied. If we would have something like this, a negative 5 to the 0, this is our base, and it's being applied. And then we have a 1, okay, because anything, doesn't matter if it's negative or positive, and then we apply the negative. So be careful with that. Even if it's inside, it's still going to be a negative 1. Now, our negative rule here, think about this as like a little house. A base raised to a negative number. We do not want exponents to be negative in final answers. They're not happy being negative. We want things to be positive. So I think about this almost like a little house. So the top floor, if everything's positive, it's great. If they're not positive in the top floor, we send them to the basement. So they'll be happy there. Maybe they want to play PlayStation or something. So we want to think about when we have a negative exponent, we're going to think about it as a fraction, like a house. Right now, he's in the top floor. He's not happy, so we're going to send him to the basement. And when we send him to the basement, he becomes positive. Now, we would have to then simplify this down 2 to the 4th power, and we get 1 over 16. But 2 to the negative 4 is the same as 1/16. And if you put that in your calculator, you'll see that it comes out exactly the same. You actually probably get a decimal, and then you can convert it. So the same thing here. Think about it as a house. He's on the top floor. He's not happy. Maybe parents are fussing at him. So we're going to put him in the basement, let him go play PlayStation, and then we would simplify this down further. Okay? Now, we can do the same thing if we have a base. It's just a variable. So we think about this as a fraction, put him in the basement, he now becomes positive. So let's talk about why these rules work. Well, think about why 2 divided by 2. 2 divided by 2 is 1. Okay? Now, we know that there's a little exponent of 1 right there. We don't write it, so I did over here so us to see it. So we think about our quotient rule. We have like bases, so we're going to keep the base. And 1 minus 1 is 0. 2 to the 0 gives you a 1. So now we know why. So when we think about this one here, we actually have 3 times 3 times 3 times 3, 8 times. 1, 2, 3, 4, 5, 6, 7, 8, and 2 here. These would cancel out, and we left with 3 to the 6th. Okay? 3 is our base. 8 minus 2 is 6. Now the same goes with we have opposite. 3 is our base. 2 minus 8 gives us a negative 6. Well, we have to flip that, and we get 3 to the 6. We can see that in expanded form by 3 times 3 over 3 times 3 times 3, 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And when we cancel those out, we're left with no 3's on top, so we think about just a 1 up there, and then we have 3 to the 6. So now we're going to talk a little bit about applying these rules and putting them to practice. So we have a couple examples here. So notice on our first example, we have bases of m, but on the top of our fraction and our numerator, we have some being multiplied. So we're going to use the product rule first. So a suggestion is to always use your simplify each area first and then apply any additional rules. So in this case, we have an m, an m, and an m, so we're going to keep that base of an m. And then remember, if we do not see an exponent, we know that there's a 1 there. So it's 3 plus the 1 plus the 8. So when we have 8 plus 1 is 9, plus 2 more is 12. So that simplified our numerator. Now we're going to look at our denominator. We still have a base of m and a base of m, so we're going to get to keep that base, and we have 2 plus 4, because that's our product rule. So we have 6. Now when we look at it, we can use our quotient rule. We have the same base of m, and so we're going to keep that m, and we have 12 minus 6, because that's what our quotient rule tells us to do. So our final answer is m to the 6th power. All right, let's look at b. So b is inside of parentheses. Think about when we do PEMDAS, we always think about in parentheses first. So we're going to look in parentheses and go ahead and simplify that. So we have the same base of x, and then we have 2 minus 8. So that gives us a x to the negative 6. So now that's been simplified in our parentheses. So now we're going to apply this 5 on the outside. So this is a product to a product, or a power to a power. So negative 6 times 5 gives us a negative 30. Well, now that you know our negative rule, we cannot have a negative exponent. So we think about this as our little house, and we're going to send him to the basement to make him happy. And we have 1 over x to the 30th. All right, C looks very complex, but we're going to take step by step. So we're going to look inside our parentheses first. So we're just looking at this piece here, and we're going to go ahead and simplify our numerator. So we have like bases, so we have y, and these are being multiplied, so we add those exponents together, and we get 5. And then the bottom, we have like bases. And remember, we have an exponent of 1 there if we don't see it, so we have 1 and 2, and we get 3. Okay, so now we've simplified the numerator and denominator. Now let's simplify the whole fraction. So we're going to go ahead and keep our base, and 5 minus 3 gives us y to the 2nd. So now we have simplified what is all in here as y to the 2nd. So I'm going to put my parentheses back around, and then we had it to the 2nd power right here. So 2 times 2 is 4. And then we had all of that to the 3rd power. Well, 4 times 3 is 12. And then we had all of that to the 5th power. And 12 times 5 is 60. So our final answer for this is y to the 60th power.